Okay, we've been talking about all these different types of numbers, how to convert them between different forms. Now we're going to give them names. We're going to work on number classification. So we're talking about in the real number system. So all of these numbers that we're going to be talking about are real numbers. We're not really going to get any numbers that are not real, and they're actually called imaginary numbers until you get a little bit further ahead in math. For right now, for 8th grade, we need to know the real number system. And we're going to start with the irrational numbers because there's very few of those, or very few types that are irrational. The first one that we should know is irrational is the number pi. Pi is a number, it's 3.14159, and it just keeps on going forever, and there's no pattern to it. And that is what makes it irrational, is that there's no end, it never stops, but there's also no patterns, right? I can't just know what's going to come next. It's just another number, and some people have it memorized out to so many digits. I don't know any more than that, but it does not have an end to it. So that goes for any decimal. So maybe I have 0.18352. I'm just going to put a bunch of dots because it's going to keep on going. There's no pattern. I can't tell what comes next. 18352. There's no pattern to it. We're just going to kind of make a note off to the side here so we understand why these two things are irrational. So they are decimals, or like pi, represent a decimal, that do not stop or repeat. Decimals that do not stop or repeat. So another example would be maybe the square root of 10, because nothing times itself is 10. And if you were to put that into the calculator, you're going to see that it is a decimal that never stops and does not repeat. So some square roots are irrational, like square root of 10, but perfect squares, ones I can take the square root of, will actually be in the rational side. So for our real numbers, there's two different main types. Irrational, these are the ones we just talked about. So pi, square root of non-perfect squares. Square root of non-perfect squares. Decimals that keep on going with no pattern, never stop, which is essentially what pi and those non-perfect square are. So then let's get into all the rational numbers. If we even think irrational, what does that mean? If someone's being irrational, being crazy, they're not making any sense. That's kind of what those numbers look like. We never know what's going to come next because there's no pattern to it, so they don't make any sense. Rational numbers make sense. When someone's being rational, they're being careful and thoughtful, thinking things through. So we'll start with natural numbers. Natural numbers are, when you're little, how do you start learning to count? You start learning to count with 1, 2, 3, 4, and 5, and so on. So these are all natural numbers. Whole numbers are almost the same, except whole numbers are, so as you get older, we learn about 0. So we start counting with 0, 1, 2, 3, 4, and so on. So notice that whole numbers include all natural numbers, plus we've added that 0 in there. So all natural numbers are whole numbers also. And we can kind of remember this if it fits inside. So natural numbers fits inside this whole number circle. So all natural numbers are also whole numbers. But all whole numbers are not natural because 0 is not natural. So the bigger one can always be part of the the bigger one. The smaller one can always be part of the bigger one, but the bigger one cannot always be a part of the smaller one. And then integers, we're going to add in the negatives. So it's going to have all these negatives, and then we'll go up to -3, -2, -1, 0, 1, 2, 3, 4, and so on. So We already had the 0 and the 1, 2, 3. What we added was -1, -2, -3, and all the other negative numbers are all new. So that's what makes up the integers. All the natural numbers and whole numbers plus the negative numbers now all together make up the integers. And then rational, in rational, we're going to have all those same numbers we just listed, so I'm going to list them all again. So all the negatives, I'm only going to write some of the negatives. The 0, the 1, the 2, the 3, the 4, and all the positives. But we're going to throw in some new numbers also. Fractions. So any number that can be written as a fraction is also rational. Decimals that stop, like 1.2. There's nothing else to it. It stops after the 2. That's rational. Or 1.75. It stops after the 5, so rational. Or it could be repeating decimals. So 2.3 repeating. I know what comes next is going to be another 3, and then another 3, and then another 3. So it's rational. It makes sense to me. I know what's going to come next. Or it could be 8.252525. Or I can write that as 8.25 with a bar over it. It's also rational because I know what's going to come next, a 2 and then a 5, and then a 2 and then a 5. So all these repeating decimals, these terminating decimals, terminating means stops, or on any of these fractions. It could be a mixed number as well. I'll add a mixed number in there. So it could be, we can add it over here, it could be 2 and 1/4, so a mixed number also. So those are all the new additions. So it's all of the natural and the whole and the integers, and we're adding in fractions, all fractions, and decimals that stop, which is terminate, or repeat. So we're going to make a note of that off to the side. For rational, decimals terminate, which means that they stop, or decimals repeat, which means they keep on going with the pattern. So we've looked at two different kinds of decimals. If the decimals do not stop, don't have a pattern, that's irrational. We talked about that up here. Do not stop, do not repeat, irrational. If they do stop or they do repeat, then that will make them rational. And then I just want to look at some examples to think about. So I'm going to write down a question. Are all whole numbers rational? And we look at the whole numbers. Does the whole numbers fit inside our rational circle? Yes. Then are all whole numbers rational? Yes, because it fits inside that circle. Well, what if we say it backwards? Are all rational numbers whole numbers? Are all rational numbers whole numbers? Does this whole rational fit inside that little bitty whole number circle? Definitely not. So then are all rational numbers whole numbers? No. So one way to remember is think about where it's at in this picture, in the circle. The smaller circle is inside the bigger. That would make that statement true. If we're trying to fit a big circle into a little circle, that's not going to be true because I can't take all these extra numbers and shove them into that smaller circle.